Hello everybody, this is Tiziano, and today we're going to discuss on how to build a drone program that will allow you to take off, go somewhere and land in just a few lines of Python. That's right, you don't need to know, involved C language or to dig into why the drone fly. You simply don't care. You focus on your added value. Just imagine how many amazing things you can do if you can give the fact that the drone flies for granted. You can do autonomous mission, object recognition, obstacle avoidance, path planning, everything without messing with the low-level code that make a drone actually fly. Back when I started, if you wanted to set up your drone, you had to actually physically build your very own autopilot, write very low-level code, figuring out how to make everything work together. In early 2000 though, DIY community arose and everybody in the world started working together on these drone code projects, and a lot of great software came out from that experience, like Pix4Stack and Autopilot and Paparazzi and so on. And those stacks actually are worth millions and millions of dollars, because if you combine the effort of all the DIY community and all the tasks that people put and the effort that people put into this code, there's no company that could afford it. Actually, thanks to this effort, a lot of professional companies, a lot of commercial companies flourished and actually took advantage of this freely available code to create their own product. Today, we're going to set up the environment in our Linux virtual machine, and we're going to create the simulator, and then we're going to write down some basic rules that will make our drone take off, go somewhere and land with just a few lines of Python. And also we're gonna be able to see the whole simulation run on our ground control station. So let's step further and follow me in this tutorial. Let's switch to the Linux virtual machine. We start off by installing mavproxy, dronekit, and dronekit-sitl, software in the loop. Then we start our simulator, choosing our latitude and longitude location and a copter as a vehicle. And then we start mavproxy, connecting the localhost on TCP port 5760 and sharing the connection to the UDP port 14551 and 14550. Then we connect our mission planner to the UDP port 14550, and as you see, everything runs like I was connected to my vehicle. Then we start writing our script. We import dronekit, especially we import connect, vehicle mode, and location global relative. Then we import time, and then we start connecting our vehicle by importing the argparse library that will allow us to pass some argument when we call the script. So we will use connect as the argument for our connection string. Dronekit can connect using serial or TCP or UDP connection. You have just to specify the connection string as an argument. Okay, so we connect with the vehicle and we print connection to the vehicle connect string. Then we have connect. Okay. Now let's define a function for takeoff and landing. So we start calling this function arm takeoff, and we pass the target altitude. We first check if the vehicle is armable, and if it is, then we switch the vehicle mode to guided, and then we arm. Now, vehicle arm is both read and write variable, so we can read if the vehicle is armed, or we can write true in order to arm the vehicle, or false in order to disarm the vehicle. Now we take off, and we use the function vehicle simple takeoff pass in the target altitude, and then we wait for the vehicle to reach the target altitude, and we check the altitude using vehicle location global relative frame altitude. And once the altitude is greater than the target altitude, then we break this loop. We now write the main program. So we arm and take off, and we pass the altitude of 10 meters. And then what we want to do is we want to set up the default speed, and we set the vehicle airspeed or ground speed, it doesn't matter because it's a multi-router. And then we want to go to this waypoint, and I'm going to copy and paste the waypoint I already set here. So I'm going to assign waypoint 1 as a location global relative of this latitude and longitude here, and I'm going to set 10 meters as altitude. And so here now, once the system is going to waypoint 1, you can do pretty much whatever you want, but as for me, I will just sleep for 30 seconds. And I'll come back setting the vehicle to return to launch mode, and then we're gonna wait another 20 seconds, and then we close connection, and we write vehicle.close, and we're good. So we test our system, we call our script, passing the connection string as localhost port 14551, and as you see, the vehicle connects and finds the quad, and then initialize the motor, and then arms and takes off. And once it reaches 10 meters, it flies to waypoint 1, it waits 30 seconds, and then it will switch to return to launch mode, and then it will disconnect. And as you can see on Mission Planner, you can follow the mission as the vehicle was real. That wasn't hard at all. And imagine how many other things you can do with such a toolkit. Now, that's all for today. Thanks for watching, and see you next time.